Hey everyone, I'm Ken Anthony.
Can everybody hear this?
I was looking forward to coming and seeing you at Reef Futures. My journey
Hold on,
as a marine biologist from
Anthony.
Move this,
Yeah.
maybe. This is a bad idea. It's gonna all of a sudden be
Hey,
like, whoa.
my journey as a marine
Do you guys hear that in the speaker?
model
Is that
developed
better?
by
No
Scott.
way. All right. So we're gonna try this again, Anthony.
Hey everyone, I'm Ken Anthony. I was looking forward to coming and seeing you at Reef Futures, but it didn't happen. Instead, I've got this video. I hope it'll do. Now, I'll be zooming in for the discussion at the end of the video, and I'll be looking forward to catching up with you then. Now, this presentation is very much teamwork. It's part of the Reef Restoration Adaptation program on the Great Barrier Reef. My co-presenters, Takuya, Rose, Barbara, they are the hard-working brains behind this talk. David, Mead, and I, we're the lucky leads on this work, and it's our privilege to be sharing it with you. My journey as a marine biologist from cold Copenhagen back in the 90s started on the Great Barrier Reef before bleaching events were a thing. Since then, we've seen this picture 6 times. My research area is systems modeling, and every project that I have been part of in the last few years comes to the same conclusion. The climate futures that we're most likely to experience this century will mean that reef management and conservation will likely be presiding over decline. Now, what does that mean? A model developed by Scott Condy and co-workers predicts that coral cover on the Great Barrier Reef will likely continue to decline to below 5% coral cover under severe or middle-of-the-road climate change. Paris, the red curve, might stabilize us above 5% cover, or maybe 10% if natural adaptation is significant. In another study led by Joni Kleypas, we showed that scenarios representative of the Paris Agreement could delay decline of corals till late in the century. On the other hand, business as usual emissions would see coral reefs crashing mid-century. The conclusion of both studies is that without additional interventions, the forecasts are continuing coral loss. So with those prospects, my modeling and decision support team were interested in understanding how we can best advise reef restoration decision makers in the face of climate change and uncertainty. First, we wanted to understand the likelihood of each climate change scenario or pathway. We were then interested in understanding what scope decision makers might have for making a difference if we were, or tried to be, smart about our advice. What you're seeing here in the first 3 columns of this table is the projected global warming for the 6 shared socioeconomic pathways in the latest IPCC assessment report. Based on the recent literature, we then assigned tentative likelihoods to each pathway. And lastly, we mapped out the scope that reef restoration and adaptation might have to help for each of these scenarios. As you can see, SSP2 and SSP4 are the most likely pathways given current commitments to mitigation globally. Our proposed scope for these pathways in the last column are stories about informed intervention in the right places that have the best chance of creating net benefits for reefs and people at scale. The last point is important because even though it's triage and it's spatial prioritization, it is with a view of creating local benefits that have a chance to amplify at scale. To help us provide this advice, we developed a decision support system that could form the interface between restoration decision makers, modelers, and restoration practitioners. The name of this decision system is ADRIA, which stands for Adaptive Dynamic Reef Intervention Algorithms. These are the principles that ADRIA builds on. It's a model-driven, structured decision-making process. In essence, ADRIA is a simulated restoration decision maker working to a protocol of objectives and criteria at every point in time and space. The first step to the right is to clarify objectives. At the highest level, maximizing reef condition, including coral cover, protecting place-based values, and supporting ecosystem services. Now, risks come in many shapes and forms in ADRIA, and ADRIA mainly navigates the environmental risks, in part by taking a leaf out of the investment playbook, specifically algorithmic hedging by seeking to minimize correlation. The environmental and ecological drivers are essentially the complex dynamic space that ADRIA attempts to navigate. We attempt to avoid stress, identify suitable places for deployment, finding larval sources and sinks that can help spread benefits and minimize risks in a reef network. Interventions are the things that reef restoration practitioners can do at every site or every time step. So these are coral seeding, moving coral larval slicks, cooling or shading, or rubble stabilization, just to name the top candidates. Here's a more intuitive way to describe the ADRIA process. We identify zones of low versus high stress exposure from heat, waves, or for example, crown thorn starfish. We then overlay these dynamic layers with spatial priorities, for example, no-take areas, marine parks. Then we resolve connectivity to understand which reefs or sites represent the best options for intervention given our spatial priorities. Lastly, we overlay these with state layers to understand how we best prioritize interventions for species and sites or reefs, given connectivity and environmental disturbance layers. Let's look at a very simple example. We want to deploy warm-adapted corals in a small reef network. Now, the brown parts in these pie reefs represent coral cover. Red in the environment is hot, blue is cool. The green box at the bottom is a priority area, for example, a green zone. The question is, where would a rational decision maker deploy corals? With this information, ADRIA would prioritize two places, reefs 2 and 4. Why? Now, reef 2 is in a cool area, so we have scope to help it. We can build resilience. It has room for corals, i.e. it has low coral cover. And it is a source reef for a reef inside the priority area. Reef 4, which is already inside the priority area and has low coral cover, is an obvious second candidate. Now, what about cooling and shading? The purpose here is to protect the standing stock of corals, again with the objective of maximizing benefits inside the priority area. ADRIA would select reef 1 here for 3 reasons. 1, it has high coral cover in need of protection, perhaps big mother corals full of larvae. Secondly, it experiences intermediate heat stress, so it needs help. Thirdly, it's a key source reef for the priority area. Now let's look at a more interesting real-world example. Simulated and guided coral interventions in the Mole Reef cluster in the Northern Great Barrier Reef, just off the coast of Cairns. Now, this is an area of high tourism activity, up to about 300,000 visitors per year in 2012, mostly on Mole Reef at the center of the cluster. Ilford Reef to the south is historically a spawning ground for coral trout. And lastly, the Moore Reef Cluster is a mixture of national parks and conservation zones. This area is also interesting as a test case for guided intervention because Moore and Elford Reefs are partially in a temperature refuge, i.e. it's consistently cooler in the center of this cluster. We saw this pattern consistently among 3 bleaching years. Secondly, we're able to resolve connectivity patterns at fine scale, here for about 300 sites within a 12 kilometre by 12 kilometre area. The general direction of flow is from north to south, but with a high potential for self-recruitment or self-seeding, especially at Thetford and Moore. Now this is critical information, together with the temperature profiles, to guide deployment. Here are the key results spatially. What you see to the left is a projected snapshot of reef condition in year 2075 without restoration, i.e. that's the counterfactual, and it's for RCP 4.5 SSP2. Now reef condition here is an indicator of mainly coral cover, but also of the coral composition and juvenile density, so partly a resilience indicator. What you see to the right panel is projected coral condition following simulated guided deployment of 5 million warm-adapted corals, about 1 year old, little corals in the period of 2026 to 2030. Now, if we can have confidence in these projections, guided intervention could mean the difference between supporting a billion-dollar tourism industry in the Cairns region versus not. What you see here are some simulation results fresh out of the supercomputer. Their purpose is to show you the expected differences between no deployment, so the counterfactual in red, versus unguided in green versus guided by Adria's algorithms in blue. I have zoomed in here to the window year 2070 to year 2080 to see what difference these strategies might make in the long term. The distributions to the right of the graph tells a story. Unguided intervention performs better than no deployment between 0 and 0.2 to 0.3 million square meters of added coral cover across the cluster, depending on sites and depending on scenarios. Now, guided intervention performs consistently better than unguided deployment, again up to about 0.3 to 0.4 million square meters of added corals across the Moore Reef cluster in that time window. Now, to close, guided intervention deployments in our example for Moore Reef cluster has scope to almost double the gain in corals compared to the unguided restoration simulations. Now, our results focus on changes in coral cover with single interventions. We think that's an underestimate. Strategies that could deploy multiple interventions at the same time and target coral species that best support values and ecosystem services in different places, we think could improve outcomes further. Lastly, the Adria team, and I speak for the team and me, we're keen to work with you. You being decision makers, restoration practitioners, investors, scientists, students. Let's develop strategies together that best deliver outcomes for reef and people. We don't have much time. We don't have much resources, really, but we have the energy, and I think we've got the capability. Lastly, from the team, from me, thank you for listening. Thank you for the opportunity to present. We would love to stay engaged with you, so I've left my contact details on the screen. I will dial in if I'm not already there, and I'm looking forward to the discussion. See you soon. Bye-bye.
No, because that's 5 minutes, definitely. Right?
Well, I don't, yeah, but I was just wondering, like, maybe hers is set up the same